Hi there, my name is Andy, and thank you so much for stopping by to listen in on my talk here on how you can create your very own naughty lists in order to automate security response. A little about me before we start. I've been working in a variety of information security roles over the past 15 years or so, most recently as a security architect. And whilst this is the first year that I have the honour of presenting at KringleCon, I've been an attendee myself for the past few years. And if my voice sounds a little familiar, well, maybe you've watched some of my video walkthroughs that I've created for previous holiday hack challenges and published on YouTube. But on to today's topic, we start with the perennial problem of passwords. If you were to see something a little like this in a log file, it should be pretty clear that someone's trying to brute force their way into an account. And the traditional approach that we'd use to deal with this type of attack is to lock user accounts after a certain number of failed logins. Now, whilst that does indeed prevent an attacker from then accessing an account if they do eventually guess the right password, it's unfortunately a really bad user experience. After all, we're also locking out the genuine user as well. This approach can also not be particularly effective against password spraying attacks, where an attacker is trying to log into a very wide number of different user accounts using just one or two particularly weak passwords. So instead of punishing the victim, wouldn't it be so much better if we could punish the attacker? After all, we know their IP address because it's here in the log files, and firewalls are a thing that exist. So can we not just find some clever way of converting these failed logins into firewall blocks to prevent any more malicious traffic from an offending IP address? Well, that's exactly what fail to ban does. It reads in log files and uses pattern matching to try and identify which lines of those log files relate to potentially malicious activity. If that activity breaches a certain limit, a ban is triggered, typically adding the offending IP address to a firewall block list for a certain period of time. It's important here to note that we only want to trigger a ban if there is a certain level of malicious activity. After all, we don't want to block genuine users each time that they accidentally fat finger their password. Now, there's plenty of guides already out there on the internet that explain how to set up a basic fail to ban instance. In this case, a jail to protect the SSH service. You just need to create a config file in the right location with these parameters. The most important is enabled equals true, otherwise fail to ban won't start this particular jail. The others relate to how much activity constitutes a ban and for how long a ban should last. In this case, if there are more than 10 failed logins from the same source IP address within a 15-minute period, then that IP address should be blocked for a period of 1 hour. Now, the precise values that you pick for these parameters is going to depend on your particular use cases and the level of risk that you want to take on. The tighter that you make these parameters, the more malicious activity that you're likely to block, but also you may start to block some genuine users as well. Conversely, if you loosen these parameters, you're less likely to have false positives blocking genuine users, but also you're less likely to detect some of the low and slow activity by an attacker. Let's see this in action. I've got this exact config configured on this server here. After saving the config, we must restart the fail to ban service for that config to take effect. In the fail to ban log file, we can indeed see that this jail has now been started, and with the parameters that we specified in the config file. On the machine on the left, I'm simulating an attacker's behaviour, in this case using the Hydra tool to simulate a password spraying attack. This command will attempt to log in over SSH to the machine on the right side of the screen, using the list of usernames provided in usernames.txt and trying the password winter 2021 for each user. Hydra starts up and initiates its attack, but after a while it just seems to hang. Back on the target server, we can see in the fail to ban log file that it has successfully identified the malicious activity coming from this IP address and has implemented a ban. We can verify this ban has indeed resulted in a firewall block by examining IP tables. So that was pretty easy, right? We just needed to create one config file with a few lines, and we had our desired effect. But in reality, our config file was just laid on top of a whole bunch of additional config that comes pre-packaged as part of fail2ban. In particular, the jail.conf file. This contains the configuration for a whole bunch of different jails that will protect a bunch of different services. Each of those configurations include parameters to define which log files should be read, the regular expressions to define what type of entry in each of those log files should be deemed to be potentially malicious, a set of parameters to define the threshold of what level of bad activity should trigger a ban, and what actions to take in the event of an offending IP address breaching those threshold limits. The filters and the actions are actually referenced from separate config files that exist within the filter.d and action.d subfolders within etc fail2ban. We can examine these folders to see what other options are available to us just out of the box. Within the filter.d folder, we can see that there are configurations here to monitor a whole bunch of different web servers. We've got email servers, we've got database servers, and a whole bunch of other stuff as well. Also, within the action.d folder, not only do we have the action to take to add an IP address to an IP tables block list, but we've got commands for some other firewall technologies here as well. We've also got commands to send an email to a system administrator to alert them to a ban. Or we've got actions here to submit an offending IP address to a public block list as well. But what happens if the application you want to monitor isn't already listed in that filter.d folder? Or what if you want to perform some kind of action that isn't already existing in action.d? Well, the great thing is you can create your own filters, jails, and actions for your custom applications. Let's start with creating a custom filter. It's as simple as creating a file in the filter.d folder that follows a certain format. The key definition is that of fail regex, and this is the regular expression to match lines in a log file that relate to malicious activity. The example on the screen here is a simplified version of the configuration for the Dropbear SSH server. It contains 3 particular formats of potentially malicious activity that may be logged in that log file. A key parameter to include in these values is that of host in triangular brackets. Fail2ban uses this to know where in each individual log file entry it can find the attacker's IP address or hostname, because of course it needs to be able to pick that out in order to take action on it later. It's a similar story for creating a custom action. We just need to create a file in the action.d folder. Some of the key parameters to set are action ban and action unban, which are the commands to run in order to ban or unban a particular IP address. Now, in some cases, there may need to be some kind of preparation in order to set up a system to accept a ban or an unban. So we have the additional definitions of action start and action stop. These are the commands that are run when fail2ban first starts that jail, or when fail2ban shuts down. The example on the screen here hopefully brings this to life a little bit. This is a simplified version of the action that's used to implement an IP tables block. The ban and the unban actions either add or remove the offending IP address from a chain called custom jail. Now, that chain doesn't normally exist, so therefore this configuration uses action start to define the commands to create that chain and link it into the input chain. Conversely, action stop then undoes those activities to clean up after fail2ban shuts down. A key thing to note here is that when the fail to ban service is shut down, it will run the unban command for any of the IP addresses that are currently banned, and then run the action stop commands to tidy up after it. So effectively, if you shut the fail to ban service down, then any bans that currently exist are undone. However, when the fail to ban service is then started again, it consults its internal database of currently banned IP addresses and will run the action ban command for any of those addresses where a ban is still in effect. Another thing to note here is that you don't necessarily have to fill out values for all of these parameters. For example, if you don't need any setup or teardown actions for your jail, you can just completely omit action start and action stop. To then actually use your custom filter or your custom action, you need to create a custom jail. And again, this is as simple as creating a new file in the jail.d folder that follows the format a little similar to the example on the screen here. Make sure that you've set enabled equals true, otherwise fail to ban will not enable your jail. You need to define log path to point to the log file that you want fail to ban to monitor, and you can set some custom parameters for the find time, max retry and ban time. You also need to reference the particular filter that you want to be applied to the log path, and also the list of actions that you want to be taken. Just make sure that your filter and your action names match the name of the config file that is created in ActionD and FilterD folders. One final word of warning though. Log files can include data that is supplied by an attacker. For example, in this regular expression, there's a user-provided username that appears in the log entry. What happens if a malicious user, say from address 1.2.3.4, specifies their username as blah from 9.8.7.6? The resulting log entry looks a little like this. However, with the above regular expression, the pattern matching stops here. This means that fail to ban thinks that this particular malicious log file entry has actually come from 9.8.7.6. With this particular regular expression, an attacker can trick fail to ban into thinking that malicious activity is actually coming from a different IP address, causing that IP to be blocked, and in effect undertaking a denial of service against that particular IP. The solution is to be as specific as possible with your filters. So in this example here, we've added the dollar symbol to the end of this regular expression to force matching to the end of the line. This eliminates the premature stopping of the pattern matching that we've just seen. Hopefully by now you feel like fail to ban is as awesome as I think it is. It really is a great baseline control for internet connected services, even if you're only using it for that basic case of protecting an SSH server. But of course, with a customized configuration, fail to ban can be applied to any application. The other key takeaway that I hope you leave with is to not be the blue team equivalent of a script kiddie. Now, I mentioned before that there's already a bunch of guides out on the internet that explain the basic fail to ban configuration for protecting an SSH service. But if you just blindly copy and paste the config, well, maybe the parameters aren't tuned correctly for your environment. And you also miss out on all the knowledge that you can also apply fail to ban to other services too. So do take the time to learn how your defensive tools work, and also how you need to configure and tune them to match your particular environment. So that's all from me. Thank you again for stopping by to listen to my talk here, and if you want more InfoSec content from me, well, feel free to follow me on YouTube and Twitter. Other than that, I hope you have an awesome rest of your day and enjoy your time here at KringleCon.